Hello friends, in this video today we are going to discuss about interpolation, Newton's forward interpolation formula, Newton's backward interpolation formula. So let me explain what is interpolation. Suppose we have a function y is equal to f of x. It is a function of x for a set of values of x. Suppose x naught, x1, x2 and so on up to xn. And from this polynomial the corresponding values of y are suppose y naught, y1, y2 dot and yn. Okay, so interpolation is the process. Interpolation is the process to find the value of y corresponding to any value of x. So that means we can write the process of finding the value of y corresponding to any value of x is equal to suppose xi between x naught and xn, and this process is called interpolation. In this method, to find the value of y corresponding to any value of x, suppose xi, two different tables are very useful, and those are, number one is forward difference table, and another is backward difference. And accordingly we will get two formulae, Newton's interpolation formulae. One is forward interpolation and another is backward interpolation. So for this given set of data we can construct forward difference table. So this is x and these are the values of y, suppose. So x naught, x1, x2 and so on. Corresponding values are y naught, y1, y2 and so on. The first forward difference that is represented by del y naught, that is equal to y1 minus y naught, and similarly we will get del y1 that is given by y2 minus y1, and the next difference will be denoted by del square y, and that is difference of these two, that's represented by del square y naught, will be difference of del y1 minus del y naught. And if you replace this 2 by these two values, then you will get y2 minus y1 minus y1 minus y naught, plus y naught, and then it will be equal to y2 minus twice y1 plus y naught. So similarly we can find del cube y and so on. Okay, so here you see this is nothing but this is a polynomial. Okay, so here these are also polynomials. Okay, similarly we can construct backward difference table. So it is same as the forward. Backward difference table. So here you see here this y minus y naught will be represented by del y1 instead of y naught, that will be represented by del y1, and this del y1, that is y2, that is equal to y2 minus y1, that will be represented by now del y2 in case of backward difference. So here also in this case you see Here also it will be del square y1, and also remember that this delta sign will be nebula in case of backward difference. Okay, this one will be nebula instead of delta. Now here you see starting from x naught, from 0 to n, so there are n plus 1 values. Okay, number of values here in this given set of uh, values, observations, and there are number of values. Here we have n plus 1. Okay, and suppose they are equally equispaced. That means conjugative difference between any two conjugative values is same. Okay, so that let us assume that x1 minus x naught equal to x2 minus x1 equal to dot dot dot. These are all equal to h. So now you see, if you write if you consider x1 minus x naught is equal to h, which implies x naught, sorry, not x naught, x1 is equal to x naught plus h. Similarly, we will get, if you take x2 minus x naught, then it will be definitely twice h, and that implies x2 is equal to x plus twice h. And for the third term, so x3, that's going to be x naught plus 3h, and so on. Therefore xi, any term xi, that will be given by x naught plus I into h, and this is suppose equation number 1. Now we have already observed that from the forward difference table we can obtain polynomials, isn't it? We have already observed that when we have got del square y naught, that is equal to y2 minus twice y1 plus y naught, this is nothing but a polynomial. Okay, so now there are n plus 1 values. So now let us obtain a polynomial from the difference table, forward difference table. Okay, from the forward difference table we can find not only del y naught, we can find del y square y naught, del y cube y naught, and hence del y1, del square y1, del cube y1, and so on. Okay, so now let us consider that we have obtained a polynomial. Let me scroll down the page. Suppose we have obtained a polynomial which is, suppose yi is equal to, which is function of xi. It is a polynomial of degree, it is a polynomial of degree n, suppose is a polynomial of degree n, polynomial of degree n, and it is obtained from forward difference table. Okay, so this is suppose equation number 2. Let us assume this is suppose equation number 2. Now here I represents I is nothing but 0, 1, 2, 3 dot dot dot, so on. Now suppose so Pn of xi, it is such a polynomial which is given by, suppose a naught, which is a constant, a1 into xi minus x naught plus a2 xi minus x naught into xi minus x1 plus dot 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 ak into xi minus x naught xi minus x1 xi minus x2 into dot 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 and xi minus xk minus 1. Why it is k minus 1? Now you see. So if you check this term, when you have 2 here, a2, and here at the end we have got x1. When there was a1, it ends with x naught. So similarly, if there is ak, so it must be xk minus 1. So hope you have understood the pattern. So similarly, we can find the nth term here. An, actually it should be n plus 1 term, not nth term. Okay, an, that's going to be equal to xi minus x naught xi minus x1 product up to xi minus xn minus 1. So hope you have understood this. Now you see, this is suppose equation number 3. This is suppose equation number 3. Okay, let me scroll down the page. Okay, this is equation number 3. From here we can find y naught. That's going to be equal to Pn of x naught, and from this equation number 3, if there is x naught, then it must be equal to a naught. So it must be equal to a naught, or we can write a naught equal to y naught, and this is suppose equation number 4. This is suppose, and this one equation number 3, and this is 4. Okay, so let me scroll up the page. Now here you see, similarly we can find y1. Let us find y1. If you find y1, then you must take first two terms. Okay, these two, and remaining terms will be 0, because when you put I is equal to 1, here this term will be 0. When you will put I equal to 2, then here this term will be 0, this will be also 0. Sorry, this one not going to be equal to 0. If you put I equal to 2, so this term will be 0. A3, from A3 the remaining terms will be 0. Okay, so now you see, let us find y1. If you put I equal to 1, so here if you put I equal to 1 here, then this term will be 0, hence this part will be 0, and in the remaining part will be also there will be also x1 minus x1, that's going to be equal to 0. That's why the remaining terms will be 0. So hope you have understood. So first we have to take only first two terms in this case. So that's going to be equal to a naught plus a1 into x1 minus x naught, and we know that x1 minus x naught, it is nothing but h, and also we know a naught is equal to y naught. We have already got used that one, y naught plus a1 into h. So from here we can obtain a1, we can obtain the value of a1. Okay, let us obtain the value of a1. Let me scroll down the page. So from here we will get a1 is equal to, if you simplify this, y1 minus y naught by h, and we know that from the difference table, if you construct a forward difference table, so we have already got that del y naught is equal to y1 minus y naught. So that's why it can be replaced by del y naught by h. Okay, this is suppose equation number 5. Now similarly, if you find y1, sorry, not y1, y2, that's going to be equal to, from equation number 3, from this equation we will get a1, sorry, not a1, a naught plus a1 into x2 minus x naught. Here I will be replaced by 2, then plus a2 x2 minus x naught into x2 minus x1. This one we will get. So let me scroll down the page. Now here you see, from here what we can write. So if x1 minus x naught is equal to h, then definitely x2 minus x naught must be twice h. So you can replace this by twice h. So what we will get, a naught plus 2 into a1 h, then plus a2. So this one will be replaced by twice h, and this one will be replaced by h. So now a naught, value of a naught is y naught, we have already obtained that, and here you see, and value of a1, we have already got a1 is equal to this. Here you can see this is the value of a1. So if you put here, then what you will get? You will get del y naught by h into h. Here h will be cancelled, so we can write 2 del y naught only. So hope you have understood this. Then here again plus we will get a2 into 2h square. This is nothing but y2, and from here we can calculate a2. So let's obtain a2 here from here. So what will be a2? From this implies a2 is equal to y2 minus y naught minus twice del y naught by twice square. Now you see, del y naught is nothing but it is y1 minus y naught, and if you put this value here, then after simplification you will get a2 is equal to y2 minus twice y1 plus y naught by twice h square. And if you check the difference table, forward difference table, we have already got that del square y naught, that is equal to y2 minus twice y1 plus y naught. You may check the difference table if you have noted this one. Now you see, let me scroll down here, a2 will be del square y naught by twice h. So this is a2. Similarly we can find a3. So now you see, so let us observe the pattern. We have got a0 is equal to y naught. We have got a1 is equal to del y naught by h. So it can be written as factorial 1 into h, and del to the power 1 h to the power 1. And similarly a2, this can be written as del square y naught by factorial 2 into h square. So if you observe this pattern, if you follow this pattern, then a3, value of a3 will be del square, sorry, not del square, del cube y naught by 3 factorial h cube, and so on. If you find, similarly we can find ak, that's going to be del to the power k y naught by k factorial h cube, sorry, not cube, h to the power k, and hence we can find an, that's going to be equal to del to the power n y naught by n factorial h to the power n. So using those values of a0, a1, a3, ak, an in the equation, in equation number 3, in this equation number 3, then what we will get? Then we will get, if you put those values, then we will get from equation number 3. So we have got this from equation number 3 after putting the values of a0, a1, a2 up to an in equation number 3. So we have got this equation, and this is known as Newton's forward interpolation formula. This is Newton's forward interpolation formula, and this formula can be simplified. Let me show you how to do that. This is suppose equation number 6. Okay, so what was the last equation? I forgot. I have given, what was the last equation? Yes, equation number 5. So this is suppose equation number 6. This formula I have got. So in order to simplify this, let us assume that x minus, and one more thing, in equation number 3 we used here xi, but I have replaced the xi by only x here. Remember that thing also. So let us assume that x minus x naught by h is equal to suppose u. Then it will implies x is equal to x naught plus u into h. So here you see, then what will be x1 minus, sorry, not x1, x minus x1, x minus x1, x minus x1. Now you see, I have already shown you that xi is equal to x naught plus I into h. So x1 is equal to x naught plus h. So if you subtract x1 from x, then you have to subtract this right hand part from this right hand part of these two. So then what you will get? U h minus h. So here h will be common, then you will get u minus 1. Similarly, we will get x minus x2 is equal to h into u minus 2, x minus x3 is equal to h u minus 3, and so on. Then x minus x n minus 1, where we are taking here x n minus 1 because here you see this equation number 6, this is ending with this x minus x n minus 1. So that's why we have to find this x minus x n minus 1. So if you find that, if you follow this pattern, then you will get h is equal to u minus n minus 1. That means here n plus 1, it will be n plus 1. So hope you have understood this. Now if you put the values, if you put these values of x minus 1, x minus x2, x minus x3 up to x minus xn minus 1 in equation number 6, in this equation number 6, then what you will get? Then now here you see this is the equation number 6. Now you see, if you put here x minus x naught is equal to, we know x minus x naught is equal to h, and x minus x naught divided by h is equal to u we have considered. So here it will be x minus x naught, it will be h into u. Okay, so if you put here h into u, then this h will be cancelled. So similarly here x minus x naught, h into u, and x minus x1, we have got this. Where is that? This one, h into u minus 1. If you put here h into u minus 1, so this thing we will get. So this h square here, this h square will be cancelled with this h and this h. Similarly, if we put all these values, we have obtained x minus x1, x minus x2, x minus x3 up to this term of this equation, then finally we will get the equation. So let me write the simplified equation, that what we will get after simplification. After simplification we will get Pn of x is equal to y naught plus del y naught u plus del square y naught by factorial 2 u into u minus 1 and dot 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 so on, and at the end we will get del to the power n y naught by n factorial into u into u minus 1. Let me write it properly. U into u minus 1, u minus 2 up to u minus n plus 1. So this formula is known as simplified. This is simplified Newton's forward difference, Newton forward interpolation formula. Similarly, we can obtain the backward formula as well. So I'm not going to show the backward formula, I will write the formula directly. Let me write the backward. So Newton's backward interpolation formula is Newton's backward interpolation formula is, so here the pattern is same. Here instead of y naught there will be yn, and we have to consider that x minus xn by h is equal to u. So in the first case we have considered x minus x naught by h is equal to u, but in this case we have to consider, in case of backward, x minus x naught by h is equal to u. Then the formula will be given by Pn of x is equal to yn plus del yn into u plus u into u plus 1 by factorial 2. So instead of del there will be nebula, I have done a mistake here. Here it will be nebula yn, nebula square yn. So, and here instead of u minus 1 there will be u plus 1, and so on, and the last term is given by del to the power yn by factorial n into u plus, sorry, u into, so let me write it properly, u into u plus 1 into u plus 2 into dot 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 up to u plus n minus 1. So hope you have understood this. So this is the backward interpolation formula. So hope you have understood this. If you like my video, please share with your friends and subscribe the channel and hit the thumbs up button if you like it. So thank you for watching.